Okay, so question number 5. Well, 2 resonance structures can be written for NO2-. Indicate the hybridization on the central atom for each resonance form. So first, let's calculate the total number of valence electrons in this ion. So nitrogen has 5, oxygen has 6, and there are 2 oxygen atoms, so we multiply this by 2. And the ion as a whole has a -1 charge, so we're going to add an additional electron to our total count. Okay, so if we add this all up, we get a total of 18 valence electrons. So now let's draw our molecule. So nitrogen is our central atom, and then I'm just going to draw a single bond to each oxygen. So now let's show if I fill in all of the lone pairs. You'll notice that nitrogen does not have a full octet yet, so I'm just going to bring one of these electrons down and form a double bond with this oxygen. Okay, so this is one of the Lewis structures of the NO2- ion. And the second one will have the other oxygen having a single bond, and the rightmost oxygen now having the double bond. Okay, so this is the second resonance structure as well. So now we need to indicate the hybridization on the central atom for each resonance form. So the central atom is the same, so we just need to do this once. But if we look at nitrogen, you'll notice that it contains 1 lone pair, and it only has 2 bonded atoms. Okay, so we would now use our VSEPR table to figure out its hybridization, and also we can see the molecular shape and electron geometry. So when we have 2 bonded atoms and 1 lone pair, we get a structure that kind of looks like this. And the molecular shape is bent, the electron geometry is trigonal planar, and the hybridization is sp2. So I'll just write that down. Bent, trigonal planar, and sp2 hybridization. So the bond angles are 120 degrees. Okay, so let's see what the junior tutor said. The resonance structures are given below. Obtaining the steric number would allow us to determine the hybridization of the central atom. So the steric number is the number of lone pair of electrons around the central atom plus the number of bonds around the central atom. This is a different method. So note that multiple bonds are counted as 1. So since structures 1 and 2 have the same number of lone pairs and bonds around the central atom, both their steric numbers would be the same. It's equal to 3. Steric number of 3 would mean that nitrogen is sp2 hybridized. The nitrogen in structures 1 and 2 have a hybridization of sp2. Yep, so that's another method of doing it as well. It's pretty much the same thing. So this solution is correct.